Summer 2008 S1 question 6. It's about discrete random variables. Part 1 asks us to construct the probability table. It's important to note that the counters are removed from the bag and not replaced. That means there will always be one less counter, so our denominator is going to decrease each time. So one draw would be the probability of selecting a gold, and that is 2 out of 6. 1/3. 2 draws would be a black followed by a gold, so that is 4 out of 6 multiplied by 2 out of 5, and that is 4/15. 3 draws would be 2 blacks and then a gold, so that's 4 out of 6, 3 out of 5, and then your 2 golds left out of 4, which is 1/5. 4 draws would be the 3 blacks and then a gold, so that's 4 out of 6 times 3 out of 5 times 2 out of 4, and then 2 golds out of 3, so that would be 2/15. And finally, the 4 blacks and then a gold, so 4 out of 6 times 3 out of 5 times 2 out of 4 times 1 out of 3, and then the probability of picking a gold for the last one is 1, so that gives us a final probability of 1/15. Part 2 asks us to find the expected value of x, and the formula for that is sigma x p of x, so the sum of the x values multiplied by their probabilities. So that would be 1 times 1/3 plus 2 times 4/15 plus 3 times 1/5 plus 4 times 2/15 plus 5 times 1/15. which gives us an expected value of 7/3. Part 3 then, the variance, and the variance of x is the expectation of x squared minus the expected value of x all squared. So the expectation of x squared will be 1 squared times 1/3 plus 2 squared times 4/15 plus 3 squared times 1/5 plus 4 squared times 2/15 plus 5 squared times 1/15. That is 7. So the variance of x will be 7 take away 7/3 all squared, which is 14/9. Remember, when you're looking at a mark scheme where a mark appears across a formula and it's a method mark, you don't get that method mark until you substitute a value into the equation. It's not enough to state equations.